And these are all the terms which would influence the soil cement stabilization. Next one, the factor which would be influencing the soil cement stabilization is the percentage of cement. How much percentage of cement you are adding? Pulverization and mixing of this, which process you are using? Compaction, which method of compaction you are using? We have discussed earlier, compaction is the basic method which we used for the soil stabilization. So compaction, method of compaction, what you are using, you are compacting it on dry side of optimum or wet side of optimum, matters. Next one is the curing. Adequate moisture content is to be retained in order to accelerate the strength. That means after the soil cement mix have been prepared, you have to properly cure its surface so as to accelerate or so as to achieve the desired strength. Certain additives also affect the soil cement stabilization. That means if you add, along with soil and cement, you add lime, the effects would be different. Along with soil and cement, if you add sodium hydroxide, if you add sodium carbonate, or you add calcium chloride, the effects would be different. Next one is the how to prepare a soil cement mix. So there are 4 points which are to be noted down. First one is the soil cement specimens are being prepared with different cement contents in constant volume modules. How you prepare the molds for cement concrete. The compressive strength of these specimens are tested after 7 days of curing. A graph is plotted which would represent the various compressive strength which is being observed with different cement content. The cement content corresponding to a strength of 17.5 kg per centimeter square is taken as designed cement content. Now this graph would be different for different type of soils. As we have discussed earlier, the factors which are affecting the soil cement mix is the type of soil. Okay. And this is a particular diagrammatic representation that is representing what is the effect of soil cement stabilization. As you all know, I have already shown in before slide about soil compaction, and I have shown you a OMC curve. So as you can see, the moisture content is on x-axis and the tri-unit weight is on y-axis. The first one is soil with cement, 2.5%, 5% and 7.5%. That means first one is soil without cement. You can observe that the maximum dry density is lower. As you increase the percentage of cement, 2.5%, the maximum dry density increases and the OMC decreases. As you increase to 5%, the maximum dry density increases and the OMC decreases, and same as in the 7.5%. So this particular graph shows that soil cement stabilization is enhancing the properties of the soil. Okay, the next type of stabilization is soil lime stabilization. Soil lime has been widely used as a modifier or binder. Just as in previous type of stabilization we use cement, in this type of stabilization we use lime. The last point is to be noted that this type of soil stabilization is effectively used in expansive soils with high plasticity index. Right? We have to go through all the types of soil for the construction process. So we have to consider, or we have to we have to evaluate, or we have to evaluate all the type of strength. That means if we have expansive soil, that means we are not going to construct. This is not the case. We have to undergo construction process, and therefore we stabilize the soil. So soil lime stabilization is effective for the expansive soil. Factors affecting soil stabilization. Soil stabilization through lime. First one is the lime content. The amount of lime content, as you increase, the effect would be different. Type of lime, compaction, curing and additive. Compaction I have discussed earlier. The compaction factor would be in all the type of stabilization, because it is a basic process of stabilization of soil. Curing and additives. This is a graph which is showing how is the change in compaction, or how is the change in strength of the soil you can observe with the varying percentage of lime. Okay, so the first one is showing soil plus 5% lime. The second one is showing soil plus 5% lime plus 1%. So the first one is the soil plus 5% lime. Second one is soil plus 5% lime and 1% nanosilica, 3% nanosilica and 5% nanosilica. The first one is, as you can see, the highest compaction, ideal compaction which we see, we see the highest dry density is soil plus 5% lime. Next is 1% nanosilica, next one is 3% nanosilica and 5% nanosilica. That means, why we are adding the nanosilica? We are adding nanosilica so as to provide soil plus lime stabilization in a different areas. For example, if we have a particular type of soil which consists of higher water content, or then we can add 5% nanosilica so as to achieve compaction. So this is the soil lime stabilization. Next we have soil bitumen stabilization. The basic principle of this stabilization is waterproofing and binding. By waterproofing, inherent strength and other properties can also be enhanced. So basically, by lime bitumen stabilization, the basic additive mixture is cutback and emulsion. And the bitumen stabilized layers of soil can be used as the subbase and base coat. As we all know, the soil subgrade pavement is divided into 4 parts. First one is the soil subgrade, subbase, base and wearing coat. So the bitumen stabilized soil can be used in the subbase or base coats. The factors affecting bitumen stabilization is the soil, type of bitumen, amount of mixing, additives and most important, compaction. Next we have lime fly ash stabilization, lime fly ash bound mechanism. Lime fly ash stabilization means soil plus lime, as we have discussed above, and the fly ash, which is a byproduct of coal industries, basically thermal power plants. The fly ash that they generate out of power generation is of no use, and we usually create blocks and bricks to construct for the construction process, and we also stabilize the soil by fly ash. So these were all the methods of soil stabilization. The most